Hi class, before we move on to the next subtopic, let's do a short review on non-parametric tests that we have discussed previously. So we've discussed the sign rank test, which corresponds to the one sample t-test or the one sample z-test. We've also discussed the Wilcoxon rank sum test, which corresponds to the two sample z-test and t-test. And in this video, we will discuss the Kruskal-Wallis Test, which corresponds to the One-Way ANOVA. Class, if you still remember, the assumptions for the One-Way ANOVA test is that the population should be normally distributed and also that the population has equal variances. Now, if either one or both of the assumptions for ANOVA is not satisfied, then we would be using the non-parametric Kruskal-Wallis test. So the Kruskal-Wallis test is used to compare three or more medians, not means, because this is non-parametric. So we use the Kruskal-Wallis test when we want to compare three or more medians. So as usual for the non-parametric test, the procedures looks a bit complicated. However, as you've discovered before this, it's quite easy to understand. So the procedure for the Kruskal-Wallis test is first, state the hypothesis and identify the claim, and then compute the test statistic value. We will first arrange the data from the lowest and highest rank and then find the sum of ranks for each group. Okay, I'll come back to the rest. We'll do number 1 and number 2, A and B first. Let's look at this example. A researcher tests 3 different brands of breakfast drinks to see how many milliequivalents of potassium per quart each brand contains. So these are the data of the milliequivalent of potassium per quart in different brands of breakfast drinks. The question is, at alpha 0.05, is there enough evidence to reject the hypothesis that all brands contain the same amount of potassium? Okay, as we've discussed before, the first step is to determine the null and alternative hypothesis. Right, class. So, similar to the ANOVA test, the null and alternative hypothesis for the Kruskal-Wallis is a constant. So, it could be written as the null hypothesis would be that the population medians are equal, and the alternative would be that the population medians are not equal. Now, in this case, the null hypothesis could also be written as there is no difference in the amount of potassium contained in the brands. And the alternative hypothesis would be there is a difference in the amount of potassium contained in the brands. So you could do it that way, or you could write it as a constant for all Kruskal-Wallis tests. The next step would be to compute the test statistics. So in order to do this, we would have to arrange all of this data from the lowest to the highest value, and then we have to rank each value. So let's do this now. We have the amount of potassium, and then we have the brands, and we have the rank. So I'll start with the smallest value here, which is 3.2, and it belongs to brand A. So the amount will be 3.2, brand A, and rank number 1. Next is 4.7, Also brand A, rank number 2. Next is 5.0. Similar, brand A, rank number 3. Then we have 5.1 and 5.2. Brand A, 4 and 5. Then we have 5.3. Brand B, rank number 6. Then we have 6.2 and 6.3, and then 6.4. Brand C, C and B, 7, 8, and 9. Next we have 6.6 and 6.8. Brand C and then B. Rank number 10 and 11. And then we have 7.1, 7.2, 7.3 and 8.2. CPBC, rank number 12, 13, 14 and 15. Okay, then the next step would be to find the test statistics. So before we do that, we need to find the sum of ranks for each brand. So the sum of rank for brand A, or I shall name it as R1, as denoted here, right? So step B is to find the sum of ranks for each group. So R1 will be the sum of rank for the first group, R2 will be the sum of rank for the second group, and here R3 would be the sum of ranks for the third group or brand C. So let's do that now. And also then we need to determine the sample size for each group. So R1 would be the sum of ranks for brand A. So I would add 1 plus 2 plus 3 plus 4 plus 5, and that's it. 1 plus 2 plus 3, and this is 15. R2 would be the sum of ranks for the second group or brand B. So this would be 6 plus 9 plus 11, 13 and 14. This is 53, and R3 would be the rest. 7 plus 8 plus 10 plus 12 plus 15. This is 52. Now we need to also determine the sample size for each brand or for each group. So N1 would be, you have 5 sets of data, so 5. N2 would be also 5. And N3 is also 5. And also we need to determine the number of groups, which is K. So we have 3 groups. And also the summation of the number of samples, or the total number of data, which is 15. And now we would be substituting all of these values into the formula for the test statistics. So the one here, this is the formula for the test statistic. So the test statistic would be H equals to 12 over the N here, 15, multiplied by N plus 1, which is 16, multiplied by R1 square over N1. So R1 square will be 15 square over N1 is 5, plus R2 square is 53 square over n2 5 plus r3 square 52 square over n3 5 minus 3 multiplied by n 15 plus 1. And we get the test statistic as 9.38. Okay, so the next step is to find the critical value. And how do we do that? We use the chi-square table where the degrees of freedom is k minus 1. If you still remember k, the number of groups that we have is 3. So 3 minus 1 is 2. So our degrees of freedom is 2. And our alpha, if you still remember, is 0.05. So let's check the chi-square table. Okay, so our degrees of freedom is 2 and alpha is 0.05, which means the critical value is 5.991. So this could be found in Appendix G in your final exam. Okay, so our critical value is 5.991. And the next step is to make a decision. So this is how you make a decision. When the test statistic is larger than the table value, so what is the table value? It's the critical value, right? So when the test statistics is larger than the critical value, then we will reject the null hypothesis. So let's try that one out. Our test statistic is 9.38. So is this greater than the critical value, which is 5.991? Right, so this is true. That means we would reject the null hypothesis. So how do we make a conclusion? Now, when we reject the null hypothesis, we would accept the alternative, which is that the population medians are not equal. Now, class, how do you write out the conclusion? You would answer this question, right? So at alpha 0.05, is there enough evidence to reject the hypothesis that all brands contain the same amount of potassium? Yes, there is enough evidence to reject the hypothesis that all brands contain the same amount of potassium. So I would be writing that there is enough evidence to reject the claim that there is no difference in the amount of potassium contained in the 3 brands. Okay class, I'll see you in the next video. Thank you for your attention.